Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a numerical or problem number 3, which is based on solution of differential equation using inverse Z transform. Now we'll see the question 3 first. Problem number 3. Obtained step response of the system described by this differential equation 6y of n minus 2 plus 5y of n minus 1 plus y of n equals to x of n. But what we want? Step response. So step response means what? We are going to substitute x of n as nothing but a u of n first. Now what we want? A step response. So to get the step response, first of all we are going to substitute my input as a step. So I'm going to write x of n equals to u of n. Now I'll substitute this value in my question. Now I'll apply Z transform on both the sides. Look at here. Z transform y of n minus 2, as basically 6 is a constant, so I'll write that 6 first. Now here the function is related by minus 2, so I'll write z to the power minus 2, or you can simply say that just place this minus 2 value in the power of z. Next, z transform y of n, which is nothing but y of z. Similarly, this 5 is a constant and this minus 1 is the delay, so I'm going to write minus 1 in the power of z, and then it is multiplied with y of z, which is z transform y of n, and at the end z transform y of n is y of z. Now look at on right hand side what we have, u of n. So z transform u of n is nothing but z upon z minus 1. Now we will take y of z common from left hand side. Now basically what we want, a step response means inverse Z transform phi of Z, which means I'm going to shift this whole part or whole product term on right hand side. So this will be appeared in denominator of right hand side part. Now look at it. Basically in this part on right hand side part, few terms are written in power of positive power of z, whereas the few powers of z are in negative. So we will convert these powers also into a positive. So here the lowest power of z is minus 2. So if I multiply numerator and denominator by the highest, that is opposite value of z to the power minus 2, that is z to the power plus 2, then automatically this whole negative powers of z replaced by positive powers of z. So I'm going to multiply numerator and denominator by z, as well as this z I'll going to write on left hand side. Now z to the power 2 is multiplied with z to the power minus 2. So look at here, the bases are same, so powers gets added. Plus 2 into minus 2, a plus 2 and minus 2 will be 0, and z to the power 0 is always 1, so we have only 6. Now here 5, z to the power plus 2 and z to the power minus 1, so powers gets added to 2 minus 1, answer is 1, so we have z to the power 1, and at the end 1 into z square is always a z square. So I'll rearrange this whole part. Now what we want, the inverse z transform we want, but before of that we can calculate inverse z transform by performing partial fraction over here. So this is one factor, but here we can obtain two factors, and what are those? The last term is always product of two digits, which means if I consider 3 and 2, so 3 2s are 6, but midterm is always addition of similar two digits, so 3 plus 2 is 5. So I can say that my two factors are z plus 3 and z plus 2. Now we have three factors, so I'm going to use three constants, let's say a, b, c. And this is nothing but my equation number 1. Now I'll multiply this left hand side denominator on right hand side. So on left hand side, we will have only z square. And after multiplying this left hand side on right hand side, what we will get? And this is nothing but my equation number 2. Now I'm going to substitute z values so that you will get the answer of all the constants a, b and c respectively. So first of all, I'm trying to remove the constant value b and c from this equation. So which term we are going to substitute in the place of z? If I place z equals to 1 in this whole equation, then you can say that 1 minus 1 becomes 0 and 0 into anything answer is 0. Similarly here also, 1 minus 1 becomes 0 and 0 into whole term becomes 0. So you will get the only for answer A. So on left hand side, 1 square is always 1 and 1 plus 2 is 3 and 1 plus 3 is 4 and the rest of the part is replaced by 0. Now 4 3s are 12 and if I shift this 12 on left hand side, you will get 1 by 12. Similarly, we will substitute another value of z. Let's say I'll substitute z equals to minus 2. So look at here, minus 2 plus 2 becomes 0. So 0 into whole term becomes 0. Similarly, look at here also. Minus 2 plus 2 becomes 0 and 0 into whole term becomes 0. So automatically a and c term will get vanished. Now on left hand side we have z square. So minus 2 square is 4. This a term is replaced by 0. Now look at here in b. Both these z replaced by minus 2. And this whole tc term is also replaced by 0. Now minus 2 and minus 1 answer is minus 3. But minus 2 plus 3 answer is plus 1. Now minus 3 into 1 is minus 3. But if I shift this minus 3 on left hand side, you will get the answer of B, which is minus 4 by 3. Now similarly, which term you are going to substitute to get the value of C? Now here, what we have? C is multiplied with z minus 1 and z plus 2. So which term is missing over here? This z plus 3. So if I substitute z equals to minus 3 in my this equation, so automatically both a and b term will get vanished. How? Look at here, z equals to minus 3, I'm going to substitute over here. So minus 3 plus 3 becomes 0. Here also minus 3 plus 3 becomes 0 and whole 0 is multiplied with b term as well as with a term. So 0 into anything is answer is 0 and 0 plus 0 is 0. So I'm going to write 0 first on right hand side and then minus 3. Minus 3 minus 1 answer is minus 4. Minus 3 plus 2 answer is minus 1. And on left hand side minus 3 square, that is z square, is plus 9. Now minus 4 into minus 1 is plus 4 and we can write 4c on right hand side and 9 on left hand side. Now I'll shift this 4 on left hand side. So you will get answer of C, which is 9 by 4. Now we will substitute all my a, b, c value in my equation number 1. So look at here, I have substituted my all a, b, c values in my equation number 1. Now to apply inverse z transform, or before applying inverse z transform, I'll shift this z on right hand side. So I'll write this constant value first. So 1 by 12 into next one is my constant term. So if I take this constant term outside, this plus sign changes to minus. So I can write minus 4 by 3 first and then z upon z plus 2. Similarly, I'll take 9 by 4 constant and then I'm going to write z upon z plus 3. Now I can apply inverse z transform on both the sides. So look at here, y of z inverse is y of n. 1 by 12 is a constant And we know that inverse z transform z upon z minus 1 is always u of n. Now the next constant term is minus 4 by 3. Here also, look at here, z upon z plus 2 we have. Now if I consider this, my a value is minus 2. So according to time scaling property, I can write this value as a minus 2 raised to n. And if I take a minus 2 common, so what we have, z upon z minus of minus 2, and minus 2 I have already solved, so minus 2 is replaced by 1. So what we will get, z upon z minus 1, and the inverse z transform of it is nothing but u of n. Similarly, here also 9 by 4 I will take constant. Here my a value is minus 3. So if I take minus 3 over here, then my whole z upon z minus plus 3 replaced by, and this is nothing but a value of a, and we know that the formula of a raised to n u of n, which is nothing but z upon z minus a. So I can write my a value as a minus 3 raised to n into z upon z minus 1, that is u of n. Now here also, if you want, then you can stop here, or else if you want, then you can take u of n common. Now I'm taking u of n common on right hand side. So what is remaining? The first term is constant, which is 1 by 12. Next one is minus 4 by 3 into minus 2 raised to n. And the last, and this is nothing but the step response of system. So that's all for now. We will solve a new numerical in new video. So for that, stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.